Welcome to Cognitia. On this channel, we explore the hidden systems that keep you alive without you ever noticing. Every living being needs to defend itself from other living beings that want to feast on it. Over billions of years, as multicellular life evolved, organisms developed increasingly sophisticated ways to survive. Today, humans have an advanced defense network, physical barriers, specialized defense cells, and biological weapons factories. But one of the most important defenses of our body is still largely unknown: the complement system. The complement system evolved more than 700 million years ago. It is an army of over 30 different proteins that work together in a complex and elegant dance to stop intruders. Around 15 quintillion of these proteins saturate every fluid in your body right now. Guided by nothing but chemistry, they form one of the most effective weapons we have against invaders. In fact, many other parts of the immune system mainly exist to activate the complement system. But this power comes with danger. Imagine having trillions of tiny bombs inside your bloodstream that could go off at any moment. To prevent disaster, our cells use numerous mechanisms to stop the complement system from accidentally attacking them. So what exactly does the complement system do? Why is it so dangerous? In a nutshell, it does three things. It cripples enemies, activates the immune system, and rips holes in invaders until they die. But how does it do all this? Complement proteins are mindless molecules, randomly drifting around without will or direction. That's actually part of the strategy. They normally float in a passive state, doing nothing until they're activated and change their shape. In the world of proteins, shape determines function. A passive protein may be harmless, but once activated, it can trigger other proteins, setting off powerful chain reactions. Think of complement proteins like millions of matches packed closely together. When one ignites, it sets off others, suddenly creating a massive fire. The actual mechanisms of the complement system are complex. So, let's simplify. Imagine you cut yourself and bacteria enter the wound. The complement attack begins with a protein called C3, the first match, the initial spark. When activated, C3 splits into two proteins, C3a and C3b. C3b acts like a seeker missile. It has only a fraction of a second to attach to a bacterium, fungus, or virus before being neutralized. If it succeeds, it binds tightly to the invader's surface and changes shape again. In this new form, it recruits other proteins and builds a platform called C3 convertase, which activates even more C3 proteins. An amplification loop begins. Soon, thousands of complement proteins coat the bacterium. For the bacteria, this is very bad. It becomes crippled, slowed, and helpless, like being covered in thousands of flies. Meanwhile, the other fragment, C3a, acts as a distress signal. Thousands of C3a molecules spread outward, alerting immune cells. These cells awaken, follow the chemical trail, and grow more aggressive as the signal intensifies, guiding reinforcements exactly where they're needed. Now, the complement system actively helps kill the enemy. The first immune cells to arrive are phagocytes, cells that engulf invaders, trap them, and destroy them with acid. Normally, bacteria are slippery and hard to grab. But the complement proteins stuck to their surface act like glue, making them easy targets. And it gets worse for the bacteria. The C3 converts. Platform changes shape again and begins building an even larger structure, the membrane attack complex. Spear-like proteins assemble piece by piece, punching holes into the bacterial membrane. Fluid rushes in, the contents spill out, and the bacteria bleed to death. The remaining invaders, weakened and distracted, are quickly finished off by immune cells. The infection is stopped before it ever becomes dangerous, and you probably never even noticed. While bacteria hates the complement system, its most important targets may actually be viruses. Viruses must travel between cells, and outside a cell, they're completely defenseless. Complement proteins intercept them, cripple them, and guide immune cells to destroy them. Without complement, viral infections would be far more deadly. So if we have such an effective weapon, why do we still get sick? Because in war, both sides adapt. Some viruses, like the vaccinia virus, force infected cells to produce proteins that shut down complement activation, creating safe zones. Some bacteria steal molecules from the blood that keep the complement system calm, effectively making themselves invisible. The complement system, while incredibly powerful, is only one part of the beautifully complex organization that is our immune system. A stunning example of how many mindless parts can work together to create intelligent defense. Thank you for watching Cognitia. If you want to understand the hidden systems shaping life, consider subscribing and stay curious.